Hi everyone, my name is Caitlin Arnold, student number Z5308017, and today I'll be talking through the bonus mark for solutions, and what we're focusing on today is Aristotle versus Newton. So the equation confrontation, dynamic law war, physics feud. I just tried to create some catchy titles. But pretty much we're just looking at the different approaches of Aristotle and Newton to the field of dynamics. So first we'll look at Aristotle. Aristotle believed that the connection between forces and motion was that the velocity of an object is proportional to the force applied to it, and he represented this by the equation F equals m times v. So pretty much this equation is the force applied to an object is equal to a constant mass, like m, multiplied by the velocity of an object. So in contrast to this, Newton believed that the connection between forces and motion was that the acceleration of an object is proportional to the force applied to it. And when I say proportional, I mean as one increases, the other one increases, and as one decreases, the other one also decreases. And so Newton represented this connection by the equation F equals m times a. So this is pretty much the force acting on an object is equal to a constant mass, m, multiplied by the acceleration of an object. So pretty much they're quite similar equations, but there's a big difference. So to explain why one of these equations is more correct than the other, I will draw upon the sport of ice skating. So in the case of this explanation, as ice has already got quite a low friction associated with its surface, we will just assume that friction is negligible for the purpose of this explanation. So let's look at Aristotle's connection between force and motion first and see why it doesn't exactly work. So if we were to apply Aristotle's approach to dynamics in the case of ice skating, it wouldn't reflect the real-world situation that occurs. This is because Aristotle predicts that when there is no force, so the F is equal to 0, the velocity is also 0, because the mass does not change. So therefore, if F is 0, then V must also equal 0. So because of this, the object is static, so it does not move. But you can see that in ice skating, this is not the case, because as we make a strong movement or application of force to begin our motion on the ice, where we're assuming friction is negligible in this case, we can keep moving even without a force to propel us forward or to pull us back. And further on this, would need to exert a force in order to stop the motion. So Aristotle's law doesn't really hold in this situation. However, if you look at Newton, so Newton's second law of motion, F is equal to mass times acceleration, this includes the inertia principle, and which accounts for the aspects of dynamics that Aristotle overlooked. So the principle of inertia states that it does not take a force for an object to move. Rather, it takes a force to change the state of motion, so to either slow an object down or speed an object up. This means that even when there is no force, the object will keep moving at a constant velocity, as it will have an acceleration of 0. So this can be demonstrated through the ice skating example, as the person will remain in motion even when there is no force acting on them. So even when there's no frictional force or there's no force of the ice skater propelling them forward. So pretty much through ice skating, we can clearly see that Newton's law is more applicable to everyday scenarios in comparison to Aristotle's law. Thank you for listening.